Good morning, good afternoon, good evening, everyone. My name is Cameron Atkins, and I'm a master's student at Johns Hopkins University studying computer science. And since May of this year, I've been working as a software developer co-op at Johnson & Johnson Global Epidemiology. In that time, much of my work has focused on the comparator selector tool, which is a tool that implements an empirical method to rank candidate comparators by their similarity to a target drug in a high-dimensional covariate space. And today, I'll be demonstrating an extension of that tool that allows a user to add a custom weighting option to evaluate comparators. So let me switch over to Chrome. Okay, the comparator selector tool was designed to solve some of the challenges of the active new user cohort design, which has emerged as the best practice for the estimation of drug effects from observational data. Among these challenges is the sometimes difficult process of selecting and evaluating comparators for appropriateness. So this is the comparator selector tool available on results.odyssey.org. For some of you, this user interface will look very familiar, but for others, let me give you a brief overview. At the top left in this drop-down menu, you can select a target cohort of interest. In this case, we have pre-selected adalimumab, which is a drug used to treat various autoimmune and inflammatory conditions, in particular rheumatoid arthritis, but you can select any drug from this drop-down menu. And if you scroll down to the bottom, we see a list of comparators. So we have sulfasalazine, sotalezumab, pegol, etanercept, methotrexate, tofacitinib. And these are all drugs used to treat rheumatoid arthritis. So this app does a great job of selecting comparators that are similar based on subject matter. You're able to see the overall rank, average similarity score, and the number of databases used for that computation. And to the left of every comparator, you can click on this arrow to the left, and you can see expanded results where you have the sample size, cohort similarity score, and the rank within each database. So in this version of the tool, the comparators are ranked by unweighted similarity scores across 5 domains: demographics, medical history, presentation, prior meds, and visit context. And the challenge and really the motivation for this enhancement is that not all studies value these domains equally. In the original model, every domain contributed the same weight to the similarity score. But in practice, for example, a safety study might care more about prior medications and medical history because those capture long-term exposures and comorbidities. But if you're running a treatment initiation study, for example, you might focus more on presentation and visit context, since those reflect the acute clinical picture when treatment begins. So the goal here is to give investigators control, let them express what matters most for their study, and see how those choices change comparative rankings in real time. So let me go over to this tab. I'll select adalimumab, and I'll click on Use Custom Weights. And that brings up this group of sliders where a user can select how much influence each domain has on overall similarity score. Each domain corresponds to one of the 5 covariate domain spaces: demographics, presentation, med history, prior meds, and visit context. And moving the slider to the right, you're telling the app that domain has more impact on the cosine similarity score, and moving it to the left reduces its influence. And down at the bottom, there's a box that shows the normalized weights in real time. This is important because if the raw slider values don't sum to 1, the tool automatically scales them so that the final weights do. And that way, the user can focus on their relative priorities. For example, making prior medications twice as important as demographics without worrying about the exact math behind the weighting. And it's also a nice visual cue for transparency. As you adjust the sliders, you can see the exact numeric weight each domain will contribute to the final cosine similarity score. And that makes it easy to reproduce results or compare different weighting scenarios later. So let's say I'm a rheumatologist investigating rheumatoid arthritis, and I'm performing a long-term safety comparison. And I care more about a patient's historical treatment patterns and comorbidities than the immediate presentation before treatment. So I'll set the prior meds to 50, medical history to 30, and the remaining domains to 10. and click on Suggest Comparators. So while this tool is running, it's recalculating cosine similarity scores within each domain, applying the custom weights selected to combine them into a new overall score. Now, this step is computationally intensive because it's evaluating a target cohort, in this case, adalimumab. It gets hundreds of potential comparators, but it uses the same methods validated in the first iteration of the tool. So like I said, it's computationally intensive. You might want to, at this time, maybe reply to a Teams message or accept a calendar invite. I timed it out. It takes about 45 seconds to render results. Okay, so these are the new comparator rankings. So I'm going to switch back to PowerPoint. We can more easily, we can see the results better. So there were no changes to the first two comparators, just minor changes to their cosine similarity scores. The ranking of etanercept has changed from 3 to 5. Methotrexate has risen from 4 to 3. Infliximab rose from 6 to 4. So facitinib has dropped from 5 to 6. No changes in the gufulimide or golimumab. And we have the introduction of 2 drugs into the top 10, as the azathioprine has risen from 11 to 9 and hydroxychloroquine from 12 to 10. So in this very specific example with adalimumab with the weighting scheme of 50, 30, 10, 10, 10, the similarity scores and comparator rankings show minor shifts after applying the custom weights, which gives us confidence in its stability. It shows that the underlying model is stable and robust, and small adjustments in domain emphasis don't completely reorder the results. But at the same time, these subtle changes demonstrate that the weights do have influence. And we encourage you to use this drug for use this app for your research to evaluate comparators with different weighting schemes. So the takeaway from this is that the weighting gives users a finer degree of control. Rankings remain consistent with the unweighted model, but users can now explore how their study priorities shape which comparators emerge as most similar.